Welcome to our channel. Today, we're diving into the fascinating topic of what a moon base would need to function. We're talking about setting up a permanent outpost on another world, a truly ambitious undertaking that pushes the boundaries of human ingenuity. Imagine astronauts living and working on the lunar surface, conducting research, exploring craters, and maybe even playing some low-gravity sports in their free time. It sounds like science fiction, but it's a future within our grasp if we can overcome the challenges. Let's explore the essentials for living and working on the moon, from the air we breathe to the ways we'll get around this alien landscape. Get ready for a cosmic adventure as we delve into the nuts and bolts of building a moon base. First things first, a moon base is going to need a reliable source of power, and I'm not talking about a few AA batteries. We're talking about enough juice to keep the lights on, the oxygen flowing, and the science experiments running 24/7. This means we need a robust and sustainable energy solution that can handle the unique challenges of the lunar environment. One of the most promising options is solar power. The moon is bathed in sunlight for about 2 weeks at a time, which means we could set up massive arrays of solar panels to capture that energy. These solar panels would need to be highly efficient and durable to withstand the harsh conditions on the lunar surface. Of course, we'd need batteries or other energy storage systems to get us through the equally long lunar nights. These storage systems would have to be capable of holding enough energy to power the base during the 2 weeks of darkness, ensuring that all systems remain operational. Another option, and one that might make some folks a little nervous, is nuclear power. Small, modular reactors could provide a constant and reliable source of energy, independent of the sun's whims. These reactors are designed to be safe and efficient, offering a steady supply of power regardless of the time of day or night. Think about it, a nuclear reactor on the moon. It sounds like something straight out of science fiction, but it's a technology we're already developing here on Earth. These reactors could be a game changer for lunar exploration, providing a dependable energy source that could support long-term missions and even permanent settlements. And let's be honest, the idea of harnessing the power of the atom on another celestial body is pretty darn cool. It opens up a world of possibilities for scientific research and technological advancements. Of course, safety is paramount, and any nuclear setup would need to be incredibly robust and secure. We wouldn't want any lunar meltdowns. Engineers would need to design these systems with multiple layers of safety protocols to prevent any potential accidents. Now, some folks have also tossed around the idea of using lunar resources, like helium-3, for fusion power. Helium-3 is a rare isotope on Earth, but is more abundant on the moon, making it a tantalizing prospect for future energy production. Fusion, the process that powers the stars, could provide an almost limitless source of clean energy. If we could harness fusion power, it would revolutionize not just lunar bases, but energy production on Earth as well. However, fusion technology is still in its early stages, and we've got a long way to go before we're generating power from a miniature star on the moon. The research is promising, but it will take significant advancements in technology and engineering to make it a reality. Next up, let's talk about keeping our lunar inhabitants alive and kicking. That means figuring out how to provide breathable air, clean water, and deal with all that pesky waste we humans generate. Oxygen is non-negotiable. We need to breathe, and unfortunately the moon's atmosphere is so thin it's practically non-existent. That means we'll have to bring our own air, or even better, find a way to make it on-site. One possibility is using electrolysis to split water molecules into their constituent elements, hydrogen and oxygen. We know there's water ice at the lunar poles, so if we can extract and process it, we'll have a source of both oxygen and rocket fuel. Speaking of water, we'll need plenty of it for drinking, growing food, and hygiene. Recycling will be key, and we're already developing advanced water filtration and purification systems here on Earth that could be adapted for lunar living. And then there's the not-so-glamorous issue of waste management. We can't just be tossing our trash out the airlock. We'll need efficient and sanitary ways to process waste, perhaps even breaking it down into useful materials or using it to generate energy. Now imagine you're an astronaut living on the moon. It's a dream many of us have had. But what does it really entail? What kind of living conditions would you need to thrive in such a harsh and alien environment? Where are you going to hang your spacesuit at the end of a long day of lunar exploration? After all, even astronauts need a place to unwind and prepare for the next day's adventures. That's where the Habitat module comes in. It's not just a shelter, it's a multifunctional living space designed to meet all the needs of lunar explorers. This is where our lunar pioneers will live, work, and relax. It's a place where they can conduct scientific research, maintain their equipment, and even enjoy some leisure time. It's got to be more than just a metal box. It needs to be a home away from home, providing protection from the harsh lunar environment while also offering a comfortable and functional living space. Think of it as a blend of a high-tech lab and a cozy living room. One of the biggest challenges is radiation. Space is filled with harmful cosmic rays and solar radiation that can pose serious health risks. Unlike Earth, the Moon has a very thin atmosphere and no global magnetic field to shield it from the Sun's harmful rays. This makes radiation protection a top priority. Our habitat will need to be radiation hardened, perhaps using thick walls, special shielding materials, or even incorporating lunar regolith, the loose soil on the Moon's surface, for protection. This regolith could be a game changer in building sustainable lunar habitats. The loose soil on the Moon's surface, known as lunar regolith, could be used for added protection against radiation. Then there's the issue of temperature extremes. The Moon experiences wild swings in temperature between day and night, from a scorching 250 degrees Fahrenheit in the sun to a bone-chilling minus 280 degrees in the shade. The Moon experiences wild swings in temperature between day and night, from a scorching 250 degrees Fahrenheit in the sun to a bone-chilling minus 280 degrees in the shade. These extremes can be deadly without proper insulation. Our habitat will need robust insulation and thermal control systems to keep the interior at a comfortable temperature year-round. Advanced materials and technologies will be crucial in maintaining a stable and livable environment. And of course, we'll need to figure out how to pressurize the habitat and maintain a breathable atmosphere. This involves creating a sealed environment where air can be recycled and kept at the right pressure. It's essentially like building a miniature Earth with its own self-contained ecosystem. This habitat will be a marvel of engineering, combining the best of human ingenuity to create a livable space on another world. Even on the Moon, we don't want our astronauts to feel like they're a million miles away. The sense of isolation can be overwhelming, and maintaining a connection to Earth is crucial for their mental well-being. Communication is key, both for safety and for keeping our lunar explorers connected to their families and mission control back on Earth. It's not just about relaying information, it's about ensuring that our astronauts feel supported and part of a larger team. But here's the thing, the Moon is tidally locked to Earth, meaning the same side always faces us. This unique characteristic has significant implications for how we set up our communication networks. That's great for keeping an eye on our celestial neighbor, but it means direct communication is only possible with the near side of the Moon. This limitation requires us to think creatively about how we maintain constant contact. If our base is on the far side, we'll need a network of relay satellites to bounce signals back and forth. These satellites will act as intermediaries, ensuring that no matter where our astronauts are, they can always send and receive messages. And we can't forget about communication on the lunar surface itself. Reliable communication devices are essential for day-to-day operations and for handling any unexpected situations that may arise. Astronauts will need reliable ways to stay in touch with each other while exploring craters, setting up experiments, or just taking a lunar rover for a spin. This ensures that they can coordinate their activities and respond quickly to any issues. Think about it. You're out on a lunar expedition, your rover breaks down and your comm system goes on the fritz. In such a scenario, having a backup communication plan can be the difference between a minor inconvenience and a major crisis. Suddenly, you're stranded on the Moon with no way to call for help. Not a good situation. This highlights the importance of having multiple layers of communication systems in place. That's why robust and redundant communication systems are absolutely critical for any successful Moon base. These systems ensure that even if one line of communication fails, others are available to take over. We need to ensure our astronauts can always reach out and touch someone, even if that someone is back on Earth, over 200,000 miles away. This constant connection is not just a luxury, it's a lifeline that supports their mission and their morale. The moon is a big place, over 2,000 miles in diameter. If we're serious about exploring our celestial neighbor, we're going to need some wheels, or rather some lunar rovers. These rovers will need to be tough enough to handle the rugged lunar terrain with its craters, mountains, and vast plains of regolith. They'll need to be able to withstand extreme temperatures, radiation, and the vacuum of space. And let's not forget about power. We can't just be plugging our lunar rovers into a wall socket. They'll need their own onboard power systems, whether it's solar panels, batteries, or even fuel cells. But rovers are just the beginning. We might also need more advanced transportation systems like lunar landers to ferry astronauts and cargo between the surface and lunar orbit, or even a lunar rail system to connect different outposts and research stations. Imagine hopping on a high-speed lunar train and zipping across the surface of the moon at hundreds of miles per hour. It would revolutionize lunar travel and open up a whole new world of possibilities for exploration and scientific discovery. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating content. What do you think is the most important feature for a moon base? Let us know in the comments below. Building a moon base is one of humanity's next great adventures. It will require pushing the boundaries of science, engineering, and human ingenuity. But the rewards from scientific discoveries to expanding our presence in the solar system are immeasurable. So keep looking up at the moon, my friends, and dream big. The future is out there, and it's waiting for us to reach out and grab it.